All right, here we go. I mean, let's just dive in, right? New unit transformations, right? Not Transformers, not that movie with Shia LaBeouf and then Mark Wahlberg and they're like doing remakes. I mean, it's kind of like that. You know, they go from cars to like big monster things, and like transformations kind of do that. They transform. So I guess it's kind of like that. Maybe I don't know. Could be something to think about. Interesting. Well, transformations. That's what we're going to be jumping into. Transformations cover several different parts, right? So we're going to go over rigid motion transformations, which include reflections, translations, rotations, then non-rigid motion transformations, which is dilations, and then we're also going to talk about symmetry, like things being the same on each side. So buckle your seatbelt, strap in, because this is going to be a wild ride, folks. Let's have fun with it. All right, so let's talk about transformations in general. So let's just talk about our friends, transformations. All right, what is a transformation, you're asking? Like, Coach Murphy, I have no idea what you're talking about. That's okay. That's why they pay me the big bucks, to explain it to you, right? And to help you learn it. Because, man, who knows when in life you're going to need this, right? So a transformation in general it's some kind of operation that takes an original figure called the pre-image, right? So we have a pre-image, right, which is our original figure, right? And we do something to it, right? We either flip it or rotate it or slide it or make it bigger and smaller, and we create a new image just called the image, right? This is our new figure, right? So as we talked about in the open, there's things called rigid motion transformations, right? And rigid motion transformations, they preserve the size, right? So a rigid motion transformation will do something to the original figure that either changes its position or orientation, but doesn't change its side, right? So the figures are congruent, right? And the rigid motion transformations we're going to talk about are reflections, translations, and rotations. Okay? Now, dilations are not rigid motion transformations because they change their size, right? So that means when we dilate something, they're not congruent, but they're similar. Okay? Hope that makes sense. It will once we get to the end of it and wrap it all up. Okay? So now let's look at reflections. Right? So when we think reflections, think about your reflection itself, right? We look in a mirror, okay? And the example I like to use is the Washington Monument, right? At the bottom of the Washington Monument is the reflecting pool, right? And when you look at it, it almost looks like the Washington Monument is flipped. So a reflection is a flip, right? Who they want? Flip, flip, flip. There's a rapper back in the early 2000s. His name was Little Flip. He was a song I think it was called Flip. His only song. Anyway, reflections. We're going to flip it. And where are we going to flip it? We're going to flip it over what's called the line of reflection, right? So we flip over line of reflection. Okay? Right, so we take that original figure called our pre-image, we flip it over a line of reflection, resulting in our image. Okay? The size stays the same, but the position changes. Okay? Remember, when we flip it over the line of reflection, each point is the same distance from the line of reflection. So each point in the pre-image is the same distance from its counterpart point on the image, right? So each point and its image are the same distance from the line of reflection, right? Now, there can be several different types of lines of reflection, right? So, let's go ahead and look at lines of reflection. Okay? So, one line of reflection we have is the x-axis. Okay? Now, when it comes to reflections, each reflection has a rule, right? So when we reflect something over the x-axis, the rule is, we got the reflection over the x-axis. The rule for this is we have our original x and our original y. This arrow right here indicates a transformation has taken place. And the new x is the same as it was before, but the new y is opposite what it was before. So if it's positive, it's negative. If it was negative, it's positive. Okay? So we can reflect it over the x-axis, right? We can also reflect it over the y-axis, right? And the rule for that is we have the y-axis. We have our original x and y. We have our transformation that occurs, right? And this time, the new x is the opposite of what it was, and the y stays the same. Okay? Now, we can also reflect it over diagonal lines, right? So the diagonal lines we're going to worry about is when it says y equals x. And that is a diagonal line that goes to the origin, 0, 0, right? And it goes up and to the right, down and to the left. So the rule for that is we have our original x, our original y, right? This time, the new x is the original y, and the new y is the original x. Okay? Now, conversely, we can flip it over y equals negative x. Okay? And that is a diagonal line that goes to the origin, but goes up and to the left, down and to the right. So the rule for this, and these rules are great because instead of graphing it out, if you just have the points, you can plug it into the rule, and it will give you the new points. So when we reflect it over y equals negative x, we have our original x and y. It is then transformed, and we have to opposite the original x, opposite the original y. Okay? Now, we can also have two other different types of lines of reflection, but they don't have rules, right? So we can have it if we flip it over at y equals a number, like y equals 7, y equals 6, something like that, y equals negative 2, or if x equals a number. Now, for these, we just have to figure out how far away each point is from the axis, right? So, those are our rules for lines of reflections. Now, let's go ahead and let's take a look at some examples on these, okay? So, it says a square is at BCD with the vertices of negative 6, 7, negative 2, 6, negative 3, 2, and negative 7, 3. Now, since we have the rules, we can solve this without even graphing it. But let's go ahead and graph it just so that we can see what it looks like. So we have negative 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7, 1, 2, 3, 4, 5, 6, 7. That's B. Negative 2, 6, 1, 2, 1, 2, 3, 4, 5, 6. That's C. Negative 3, 1, 2, 3, 2, 1, 2. And negative 7, 3, 1, 2, 3. Right? So there is E. Right? So, right? Now, if we want to do this without the rule, we would figure out how far away, because it's reflecting it over the y-axis, right? So here is our x-axis, Here's our y-axis. We're flipping it over this line right here in red, right? So our pre-image, which is our original figure, right? Right, we're gonna flip it, okay? And it has to be the same distance. So our new C is 1, 2. The image is called C prime, right? So our new figure, how we know which one it is, it's denoted with that little prime sign, right? Now, where is B? So B is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's our B prime, okay? D is 1, 2, 3. 1, 2, 3. There's D prime. And E is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's E prime, right? And we have now flipped or reflected this shape over the y-axis. Now we can use our rules and go through, right? So our rules for when we reflect over the y-axis is that x becomes opposite and the y stays the same, right? So we would have 6, 7, 2, 6, 3, 2, 7, 3, right? So we can figure that out without even plotting these, but I wanted to show you guys what it looks like, right? So let's take a look at this one, right? We have y equals 1. So we go where y equals 1, which is right there, right? Let's go ahead and make our line of reflection, right? Then we can go ahead and plot these points, okay? So let me get a different color here. We have -4, 1, 2, 3, 4, 3, 1, 2, 3. Right, we have 1, 2, 1, 2, 3, 4, 5, 6, 7. We have J, K, we have 2. 1, 2, 7, 1, 2, 3, 4, 5, 6, 7. And we have 1, 2, 3, 1, 2, 3. Right, got ourselves a good old-fashioned trapezoid, right? Now we're going to reflect it. Let me put these in here. We're going to reflect it over y equals 1. So now we just have to make sure that our new image, right? So this is right here, 1, 2. This right here is 2. This right here is 1. From this red line, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? So now when we flip it over that way, we've got to make sure that those new points, the image points, are the exact same distance away. So 1, 2, we have M prime. Right? 1, 2, we have J prime. 1, 2, 3, 4, 5, 6, we have K prime. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. We have whatever that one is. Right? Now, we go ahead and connect them. And now we have our image. All right? So we have to make sure that we are counting and making sure that each prime point is the same distance away from the line of reflection as the original point. All right? Now, if we can go one way, we can go the other. Right? So we can always figure out, you know, what axis we flipped it over. Okay? That's pretty much all when it comes to reflections. Remember, we're just flipping it, and we're making sure that the figure is the same distance away from the line of reflection as its original shape, right? So with transformations, the big thing is remembering the rules. They can get a little bit confusing. If you forget the rules, just remember it's a flip and it's got to stay the same distance away. All right. I hope this helps. I hope you guys understand this. Any questions, leave them in the comments. I'm out.